Okay, thank you very much. So I'm happy to be here together with my colleague Milan Mladoniczky, who is my former student, and Lubosz Petrovic here will also help us with some demonstration. And I'm quite happy to be here in GeeCON. We are first time here, and we will speak about object-centric processes, combining process modeling with object-oriented programming, somehow attaching the life cycle to objects in form of workflow processes. But more or less it will be about low code, and we didn't trust ourselves to put that in the title because you all here are real Java coders and Java developers, so low code could be somehow provocative for you. But let me tell you some facts that I found it in Gartner predictions and in some Forrester reports. So low code first time as a term was probably used or is referred to 2014, so less than 10 years ago, to define some development platforms that are simple and easy to use. So not very precise definition. So nowadays almost everything is now low code and sold as a low code. So maybe we should think about what should it be, what should be requirements for such platforms, and maybe, as we will see later, maybe we will need some languages that will support those platforms. Another fact that I would like to mention is that what Gartner predicts, that not we are saying that, but Gartner, and maybe they are wrong, maybe they are right, but if they are right, then it seems to be that in a couple of years there will be like 3/4 of new applications developed by or for enterprises will be using some low-code, no-code platform, in comparison to nowadays when it's less than 1/4. Yeah, so a change will come if they are right. So maybe they are not, but it doesn't mean that for real developers there will be actually no place on the market, because what I also read in that report is that today we have like 27 million developers, roughly, according to them, and around 8 billion people in the world. So far less than 0.5% of living people, humans on the world, are software developers. And at the same source, you could read that they expect to have 85 million or exceed 85 million in 7 years from now. So what does it mean? It means that some people will retire that are today developers. So we definitely, if they are right, need more than 50 million people. They will develop applications. So it's more than double, or something like double of the people they are today developers. And I was 30 years, now they are 30 years now, I am teaching at the universities courses on object-oriented programming, Java, C++, application development, web services, whatever. So all these things. So I'm teaching that because I never could deliver applications. So when you don't know, so you are teaching. But during these 30 years, I slowly learned something. Yeah. And what I see that really, when we had 300 people in the first semester, at the very end, we had maybe 80 that finished bachelor degree, and 20 of them could master Java somehow. So it means that if we want to have 50 million others, maybe we that are developers today should not think so much about delivering custom applications to end clients, but working on such platforms that will enable develop applications to other people they are not able to develop now. And this is what we are trying to do. And I will actually start going back to the past. And I'm asking myself, what is actually programming? Or programming or programs is actually a way how humans tell computers what to do in languages, in programming languages that computers understand, such as machine code in the beginning, but people don't as much. Yeah? And therefore, over the history, we see these attempts, this effort to abstract from some features in programming languages of today and to bring new generations of programming languages that will be easier to use. Like, for example, assembler abstracted from physical addresses of machine code. And later on, we had another programming languages. The talk before, we have heard about COBOL, which started it, 1959, when I'm good to remember. I was born 10 years later when COBOL started, and it's still here, maybe not so widely spreaded, but still here. So some of those languages like Fortran are maybe obsolete today, but those like C, C++, and later Java, different object-oriented programming languages like Golang, Kotlin, or whatever, Rust. So there are plenty of them, yeah? But with coming of internet, the situation became even worse because, because the problem is that usually the applications that we are focusing on, like reactive web-based application with front-end running in internet browser, so you need to have a front-end developer who should master HTML, CSS, JavaScript, TypeScript, maybe React, maybe Angular, maybe Vue, and also kind of basic of web design and UX. You also need to have a persistence layer, so you need to have database specialist, an SQL specialist or no SQL specialist. You need to have some guys that will admin the systems, that will do DevOps, know operating systems ranging from Unix, Linux, Windows, knowing maybe some cloud technologies and virtualization platforms, and security guys and network guys, etc. So this picture is mess, but it's even not complete. Yeah, and you also see from other side of that bridge that the business people are trying to bring some analyst and consulting stuff that we all remember 20 years ago when model-driven architecture and model-driven development came, and actually people starting to use some visual languages or visual formalism to draw data layer or to draw like message sequence chart, life sequence charts, BPM and process layer workflows, etc. So, and if we just continue this trajectory from the history, so, and if we take, for example, that Gartner report, so it seems that the low-code platform should be some kind of the last layer now in a couple of years. Yeah? And instead of all of this, maybe instead of all of these specialists, we will have some low-code platforms where people can drag and drop and do something. I personally hate when somebody say about no-code, because it's like when somebody says, okay, in old Egypt, when were these hieroglyphs, and somebody says, okay, it is just 0.35% of people understand that, so we should forget the writings. We should just show people how to do things like cooking, etc. We shouldn't have something written down like, this is what should we do, no algorithms, nothing like that. So if you have no code, so you have no writings, you have no languages, it doesn't work. So instead of that, I believe that we should work as a community on the languages that will support those low-code platforms. So that shouldn't be platforms, it should be languages that support those low-code platforms. And before we start to do that, actually today, 2 years ago, Microsoft came, they have this famous Power Apps low-code platform, supported by Power Automate for workflow processes, and at the very beginning they say, okay, this will be low-code, no-code platform, but 2 years ago they announced a Power FX language, which should be a low-code language supporting that platform, for example. Yeah? So this will come, and we should, before we start to define those languages, we should maybe think about what are requirements on those languages. Yeah? So for example, we believe personally, if you have seen that math, so maybe one thing, similar as we abstracted from physical addresses in assembler, from machine code, maybe we should abstract from those layers and let the platform automatically create an application layer and data layer and presentation layer, and all the communication between those layers should be done by the platform itself, but it should be possible to define how it should behave in a language. And one possible way is that this language is a vertically all-in-one definition of an object. So we should not have a definition of a table in a database and then maybe a Java bean on application layer and then maybe some JavaScript variables in the front end, where we should have just saying, okay, we will have this attribute of the object, and the object should have for sure some persistence layer, but the platform should decide when the data from the application layer should be written in the persistence layer and back. And we shouldn't maybe take so much care about what, as a low-code programmer, what kind of application layer is there, or what kind of data layer do we use. For sure, it should be parameterized. There should be connectors to existing technologies, etc. But this is maybe one possible way of abstraction. And one important thing is, okay, so when we started with object-oriented programming, so what we had how it started. So we had structures. Those they are older, remember, at the very beginning there were structures without methods. Just to say, okay, we have new data types with different attributes. And after that, somebody came and said, okay, we should have methods that manipulate with those data attributes as a part of the definition of a class. Yeah? But we don't have explicit life cycle of those data. But people in business, they model different workflow processes, saying like, okay, I have a request, and somebody is submitting that request, somebody is registering that request, maybe somebody is processing that request, then the requester gets the answer, etc. So we can take a look on each and every object. Can be a data object, but it has a life cycle. Is a car a data object or a process? If we take a perspective that it's some order for the car, then it's assembled, then it's shipped somewhere, somebody is driving that car, maybe 10, 15 years, 200,000 kilometers. So we can understand car as a process. And at the same time, we can understand this is as a data object with like color, engine, horsepower, I don't know, type, etc. Yeah? And this works for every object. So we advocate that maybe we should extend object-oriented programming using all of the advantages and add a workflow process to define the life cycle of the data. Not just have a constructor and then implicit like life cycle by methods calling one other, but having really a workflow for the life cycle of that concrete data type. And because usually workflows nowadays or business processes consist of tasks, and according to our experience, tasks may either be automatic or or system or computer executed, or can be executed by humans. And if they are executed by humans, then they are actually forms. So, and if we attach forms to tasks, so we have a vertical objects where we have a structure of data, we have a life cycle in form of a workflow process consisting of flow of the task, and the tasks themselves have associated forms. Yeah? And we have events on those things, like assign task, finish task, set data attribute value, or change data attribute value, etc. Yeah? And we can react to those. We can react to those events with pieces of code where we can trigger another event. So I can say, okay, when this task is finished, please create a new object or assign task in different instance of a different process or a different object to another user or something like that. And we can make chains, synchronization of events. So what does it mean? It means that we actually can have interconnection relationships, not only on data layer, typically like we have to one-to-many or many-to-many connection on databases or objects with references or foreign keys, but we also have the possibility for those vertical objects to communicate via synchronization mechanism between events. Because reaction to one event can be triggering another event in different object. Yeah? And we also can have communication or interconnection on the user interface layer, because we can say, okay, we will assemble a form from other forms of other processes as subforms. Yeah? But we have clean, separated objects. We don't have that messy stuff that somebody is designing database, somebody is designing processes, and somebody is designing screens, and like spaghetti joining one layer with another layer. With one process working with seven classes, 7 beans, or one forms like having 5 different tasks directly in that, etc. Okay, so just to make a summary, so we have data objects which are like standard classes with attributes. We have adding lifecycle to those data objects. Instead of methods, we are attaching a workflow process that consists of tasks and explicit states. This is also what we would like to have. And so for sure we have concept of roles, or should have concept of roles and users. And we should also have these pieces of code reaction to the event. In our implementation of these concepts, we use Groovy for that, because as Milan will show you, we can dynamically compile those pieces of code, so without rebuilding the Java application, when all of this low-code language code is running as an interpreter. So we doesn't need to recompile, rebuild the application every time we upload a new process. So therefore, we use here in actions, we use Groovy language. And what we should also have is a query language. This was actually probably one of the main reasons why SQL was so successful, was because the query language was really powerful and enabled to manipulate or to find data according to searching criteria. So query language that will searching for instances of those process classes, or how you call it, task and users, is quite important. Okay, I will skip this slide maybe, or maybe here I will just say that it's quite important that you don't only have this like drag and drop layer where not so real coders can do something. You have this action layer where you write in Groovy these reactions to events, but you also should have a layer where you can extend that language. So the language should be, in some sense, open to extensions, both on application layer, like writing something in Java, classes with methods, compiling, and then those classes and methods could be called in this low-code layer. And the same for components that will be used for assembling of user interface. So you should be able to enrich the language, adding new components. Okay, maybe now I will ask Lubosz to make a really small showcase how it can work. So we prepared a very simple application to illustrate this concept, where we want that anonymous user, we go to an internet page and we'll fill a form with name, surname, email, and phone number, and write some text. Milan has a company, and he wants that the people can send him some requests in that way, and the employees at the registration desk will have a task that where they will register the request, and based on the data in that request, they will decide whether it should go to legal department or it should skip the legal department. And if it goes to legal department, then legal department should write a statement. Then those two alternative ways in the workflow should join together, and there should be the last task where people from PR, public relation department, are writing very polite answer to that request. And all the time we want that the person who submitted the request see a status, so a screen or a task or a form where he sees what he submitted and in which state his request is, and when the answer is ready, so then the user should see also the answer on that screen. So we can start with that. So as we said, we have tasks. Tasks are rectangles. So we are saying that these tasks and tasks can be associated with forms. So this is a form for the request itself. So give that the name, surname, email, and phone number. You can make email required, and you can make this text for the request itself. And dragging and dropping these data fields, I am creating at the background the data model itself with those attributes. Okay. I can rename the IDs, etc. So now I can make a workflow, life cycle of the data, and I'm saying, okay, at the beginning there should be a task where we submit the form, or the user submit the form, submit the request. Then should be the registration of that request by people from registration desk. Okay. Now we want to have two system tasks. One will go to legal department, and they will be fired based on the decision at the registration desk. And another is skip legal department. And these circles are state variables. They are control state variables that can hold token and move those tokens according to those arcs. We will see in 1 or 2 minutes. Yeah, and after that we will have this answer. Okay, can you make answer? No. This is good. This was good statement. The last task. Last task. Answer of the PR answer. And we also want to have a parallel branch after submit the request. So we are saying we have a parallel branch there, and this task should be a status of the request itself. Okay, now when we have it, so we can build the forms for all of the tasks, and we can see how we can reuse forms that we already have. For example, here when he clicks on create form, he will add a new data field like task reference, so reference to another form or another task, and he will change the ID, call it like, can you change the ID to reference to request or to form, request form, or you can say request form for request, doesn't matter. Okay, so what this means, and initial value is T1 here. So actually it means that, go back, that when you can now go to simulation mode. What is actually happening that if somebody submits to detailed simulation mode, so when somebody is assigning this task to himself as a user, so in that moment this form is actually a subform of this one, because we can have state attributes, or we can have attributes of a process to be tasks of the process. Okay, now the registration, it's quite easy. We will have just Boolean variable or attribute, go to legal or to legal department, or however you want to call it. And we will also have this submitted form as a subform, but now just visible, because when something is submitted, we doesn't want to change it. Okay? To legal and skip legal are system tasks, or will be system tasks. Now we want to make a form for statement of legal department. Here we need a new text field, which is bigger, which is called statement of the legal department. And you can change the ID. You can also change ID. Okay. And we also want to have the request form, submitted request form as a subform, just visible. Yeah. In similar way, we can go back. In similar way, we can make answer to the request itself. So a new data field, which is actually added to data model on the fly. Like building the forms, I'm also creating the data model. Okay, changing the ID. And I want to have this statement of the legal department there too. But at the very beginning, I want to have it hidden. I want to have it hidden. Okay, because sometimes it is going to the legal department, sometimes it's skipping. Okay, and I always want to have a visible subform of this submitted request. Okay, and the last thing I am doing is status, where I'm adding a new text variable status, when I will write a string like it's submitted or it's registered or etc. So it will be called status. Can you change also the ID? Okay. And now I want to have answer there, also hidden at the beginning. I will make it visible after it is answered. And all the time I want to have there the submitted request as a subform. Okay, perfect. And now we can go to roles and users. So we are saying, okay, we will have a registration as a role, or registration employee, registration. We will have PR, and we will have legal department. Okay, and actually a system. Okay, and because we don't want to approach the form itself directly, so we will say it is a system task. So it means that only can be approached through another task or directly by the system, so by somebody that has the role. And these two are also system tasks. Okay, and now registration is a task for employee of a registration desk. And legal department should make this task. Answer should be done by people from PR department. And status and submit the form can make anybody. So we have a special role which is anonymous and default. It means default means any user that is registered, and anonymous means that any anonymous user can do it. Okay. So and now we just will he's like just changing some meta attributes of the program in that local language. Now we will work with that actions. So here we will say, okay, this task has finish event, and we will say in this finish event we want to change the value. Okay, change the value of the variable status to the string your request was submitted. Now the similar way we want to have in registration. So he just like going in the list of the task and saying, okay, here on the finish he will just change it to your request was registered, and you go to the last one. Everybody can, we will go there, and here we will see your answer below. Okay, we will use this field. Your answer is below, and we will make this answer on the status task visible. Okay, so you will change behavior. You will make data field answer of the PR visible on the task status always. Okay, and in that way he wrote this piece of code in Groovy, which is calling some pre-compiled other API methods. And actually we want just one thing, another action. Legal department, go to legal department. In here we should change behavior of the data field statement of the legal department to visible on transition answer. So because when they write something, PR people want to see the statement of the legal department. And the last action we are doing, and then we are finished, is this decision. So okay, we are in post adding a function, a basic function, if else statement, and saying, okay, if that one, this Boolean to legal is true, then system should fire or execute task, go to legal. And execute task means assign to the system and finish. Okay? So he is like saying when it should go to legal, so that task, the system task going up will fire, and otherwise the system task skip the legal will fire. You can now simulate the whole thing. And actually it's like, okay, when he's filling the form, somebody is registering the form. And here, according to this Boolean, go to legal, skip legal, either is firing, assigning, and finishing the task to legal. And if yes, then the people from legal department have to write a statement. And then somebody from PR department have to write, somebody from legal PR department have to write to answer, and all the time the submitted request is visible by the user in the task or form or screen status. So now you can deploy it in an interpreter of the language in cloud, which everybody can try. It's available at the address. Don't do that now. Milan will do that. Okay. So if you register to a task Netgrif Cloud, so you can create your account, you can upload this generated source code in that language Petriflow, that we what is that? Okay, and now when you go to he used to go to anonymous mode of the web browser, and if you go to that address that he copied, the new instance new object of that class is created, and he is just making this first task as an anonymous user, filling his form. So it's already deployed. So it really takes 10 minutes to make applications with that. So it's really speed up the process of building applications. And after he did it, after he submitted the request, actually he can go back to that cloud version of the interpreter. He can manage his roles, and he can say, okay, he will now play the role of the registration desk, and he will see that he has the task registration there according to the workflow process, and he will just now decide that it should go to legal because somebody wants to do something with the contract. Okay? And now if he is changing the, you see that status was changed, so your request was registered. So the person who submitted the form see that it is actually in further state. And now he can go back and say that he is a lawyer because he is a multi-talented guy, as one of my former students. And now he can actually write a statement. Okay, and after he writes a statement, and now he can change the role and say that he's a PR department employee, and he is writing the answer. You see that the statement of the legal department here down below was actually making visible from hidden, and he's writing a polite answer. For sure, he can go and send an email. He can, in this action, we can send email. We can create PDF file, and etc. etc. We can make web services, etc. etc. So, and we see that he, as a user, now sees the answer that he got from the PR department. And actually, that was a small showcase, and I will ask the technical guy, Milan Mladoniczky, to show you how, as a Java developer, you can extend that low-code platform.
Okay, so hello everyone. I will be very brief. Okay, so back to the presentation, and then just skip some slides. Okay, so how I start presentation from here, or I can do this. Okay, so basically what you saw was this application engine front-end, application engine backend. The backend is written in Spring Boot and some other modules, and we add a processing layer and a Groovy shell on top of that, and the UI is rendered in Angular. Currently, we have two connectors for MongoDB and Elasticsearch, but we're trying to expand on that. So basically, the technical architecture is a monolith. So it's deployed as a one monolith, but you can tweak and you can extract some modules you don't have or you don't need to have, or you want some write your own. So basically, on the bottom is a JVM. There is a Spring modules, and there is a Groovy shell for just-in-time compilation of the action of the processes. And there are three distinguished parts, like a process engine, then runs the task, runs the cases, runs the instances, the roles and permission that handles the authorization and authentication, and why, when, which user should have done some task, etc., and the action runner. And then on top of that, we have two APIs. One is a REST API for communication to outside world or to engine client, and another is a gRPC to communicate between different instances of the engine or between the plugins and the engine. Plugins is in native Java, so you can write your own, then register to the engine. You can extend the functionality of the application engine itself. And then, as I mentioned, the presentation layer is built on top of the Angular. So we have two libraries. One is the engine Angular library, and one is a component library. Why two? Because when some designer designs some views and it's in Photoshop or Figma, it's quite great, but you need to implement it in CSS or HTML and JavaScript. And you don't need to know the background layer, how to communicate to the engine, how are the REST API, how is authorization, etc. So this is where your parts come in. You can have your own component, engine components replaced with your components, and you don't have to change anything about the communication or the logic stuff and the front end. And it's the same about the backend. So you can have deployed your processes to the process engine, and it automatically, like you saw in the demonstration, it executes your logic. And of course, if you don't like the standard API or want to extend the API, you can use plugins. So how the just-in-time compilation works in our case. If you upload the process, like you saw in the demonstration, the importer service runs through all the code, through all the XML, and looks for the action snippets. And when the action snippet is found, it's pre-compiled and wrapped into the Groovy closure. So that is the first time it's an almost compilation, as I would say. Because as you saw on the demonstration, the snippets of the code has two parts. One was the local variable definition, and one was the code itself, like change the behavior, etc. So that's with the import part. And when the event is triggered, an engine detects that there is an action for the event, it compiles for a Groovy shell and injects with some custom rules. For example, on the cloud version, you don't want some random people to mess with file system, so it's banned there. But can also inject the action API, yours or engine or natively engine. And then it is runnable closure. So in closure, we inject another context. We call it the process instance context. So the action knows for what instance, for what user, for what event runs, and then runs the action. And from the action is the event outcome. As Gabriel said, the action can trigger another event, and then can trigger another event, and then another event. So the event outcome, it's like a tree that is building up. And when the all event chain ends, the event outcome is a delta of all changes that happens in the system on that one trigger. And we can propagate that to the UI that can change accordingly for the user or to another system. So how is it deployed? Basically, it's a Java application that can be deployed on the cloud or on-premise, like for virtual or VPS, etc. And then you have a custom process logic that you deploy to the server, Java server. Every process is a semantically versioned, so like you are used to in code, when you deploy something, it has a version. So with processes, we have also the same. You can state that is a major page, minor is a major release, minor release, or page release, and then the engine accordingly import that process and circulate the instances accordingly. Of course, if you have already run the system, for example, you have a 500,000 instances, and then you deploy a new update, you can choose. Do I want to migrate the old instances to the new process, or the old process just stay as is, and new instances are created from the new version of process. So the developer can choose. When I want to migrate, you can also put migration script with the process deployment, and the engine runs it import event. So in cloud, it's quite different than typically on-premise. You can strip the engine only for the process layer, and the authentication and role management go to the gateway. So when the request gets to the cloud deployment, the gateway decides if the user can request that instance or can do the task, and then ask the operator, which has process discovery service, that the operator knows what process runs on which engine worker, and then reroutes the information to the appropriate engine worker. The operator also is a Kubernetes operator, so you can deploy all the cluster with that. Okay, and I now show you some basics. So, okay, I don't know show anything right now. Yeah. Okay, now, so I have a very basic Java project. This is we call the starter project. So we have two starters, one for UI, one for backend. So the project itself consists of already prepared some classes, configured engine, configured connectors. Also, you can tweak it yourself. But the two main interests when you start is a custom action delegate, which is the extension of the standard API what guys use. Then you can write custom code, whatever you want. And however, the project itself runs on Spring, so you can auto-wire new Spring components. You can inject it into your Spring project. And another is a runner. So runner is something you is run on the start on the application. So like guys imported the process dynamically on the already deployed engine, and I want to deploy, and I want some processes to be deployed when the application starts. So when the user starts clicking, it's already there. I can do it in the runner. So we have some API for the two. So I can just go to the downloads where the process should be. This is the one, I think. So I move there. Yes. Okay. So I have a folder for Petriflow, which is automatically scanned for all the processes, but I can have it anywhere. And I just type for import helper.i, and I have several methods I can choose what I want. And I want create net. And all I should do is just write the name of the file. Hello, computer, okay. Request.xml. So, and now when I start it, we should see that the process itself was already imported. Okay. This is great, but runner starts every time I start the application. So when I'm in cloud and container just spontaneously is down and then up, the process itself is imported again. So as we already saw in the logs, somewhere here, we have a custom runner finish and imported request process. But when I want to do only one time in all the deployment area, I can refactor this. I cannot. Okay, to another class, which is migration runner. A migration runner is only different with that can be used for the migration purposes, or when I want only run some code only one time at the start of the application. So when I do this, the process will be imported only once. And I have a minute to end, so I just go to the Slido if there are some questions. This was the URL. Okay, so what about maintainability of it, performance, complexity? Doesn't this seem to be solving the original problem? So if it is a standard Java application, so we have implemented open telemetry connectors. It is already deployed on several companies, around several thousand processes at once. So you can update it if the engine is updated, the processes stays. So we have a backwards compatibility for like 6 years down. So I think that's quite itself. Performance complexity, it depends, because you can have a simple process like guys showed up, but you can have pretty huge processes, and you can have application that consists of several thousand processes that connect with each other and trigger event between each other. So the complexity of the application can be quite huge. And then you can scale it up. So you can say that some processes about car insurance, for example, there are several of them. and some that handles the user request are run on one engine instance, and that handles some documentations and some back office stuff are handled on another. And then the engine itself are communicating between itself. So you as a Petriflow or local developer, who doesn't have to know where the how the topology is. Okay, so this is the most compelling example of local. Everything quite nice. Oh, thank you. Okay, I think we have a time. Okay. But if you have another question, you can meet us here.
Okay, yeah. Thank you very much.
Thank you very much
for your attention and